Well, hello and welcome at our webinar CANopen Industry 4.0. My name is Oskar Kaplun and I will lead you through today's 1 hour introduction of what we as CANopen Automation have already done to support our members developing internet-based solution in CANopen networks. So, while I do some organizational stuff explaining now, I would like you to read our requirements in general for these webinars and all events we do online. Then I would suggest we will start. I would say a few words about me. I'm working already certain time at CANopen Automation, and I'm an engineer and do some various things at CANopen Automation. On one hand, I do as CANopen Automation maintains specification, assist our technical groups in maintaining the specifications for CANopen-based device application profiles. And on the other hand, I'm a test engineer testing devices for conformance to CANopen protocol. We will have a couple more slides giving you introduction in CANopen for those of you who have not been in contact with us. It will be a nice opportunity to know what we are, what we do actually, and where we're located. You can see in this slide. You can contact us by all these various means. And CANopen Automation was founded to provide product technological information support for CAN-based technologies. Since the development of CAN was a request, a necessity to bring this into the bright public, how the CAN works. So CANopen Automation was founded, and in the first place it is a membership-based organization. So we have up to now about 700 members. It started more than 25 years ago. And as you can see, the number of members grown and is held constant over the time, meaning the interest to CAN-based technology is still on hold and still continue to interest people. So CANopen Automation has, as an organization, offers this product information support for CAN-based technologies. So we have two activity branches. On one hand is this technical branch, which is affiliated with the working on specifications. We have various specifications committees consisting of our members who would like to develop specification in certain, for certain directions, certain markets, and so on. And as you can see from this slide, there are various technical groups for various technical CAN-based technologies we currently maintain. The topic of today is CAN in Industry 4.0. This is more industrial application and rather IoT related stuff, which you can see on the far left piece of IG CANopen and profiles, where we do design this specification. There are plenty of specification to this topic, and this slide should give you just a basic overview where we are on this one. We have also IG 9039 technology, also CAN-based technology, where we do specify profiles, CANopen mapping to J9039 networks and protocols. We have also safety and security working groups, maintaining various aspects of safety and security in embedded networks. We have device profiles, as you can see, IG profiles, where specific area of application, devices and applications are addressed, and we have very certain frameworks we define, specify with IG CANopen and IG CANopen FD. This is new based technology, CANFD based technology. So you can see we have plenty of application areas for CAN-based technologies, and I have plenty of working groups, many specifications. This could be something that you find here will be useful for you. So, on the other hand, we would have to know, and especially triggered by our members, how should we spend money of the organization coming from our members to promote technologies, CAN-based technologies, and also assist our members in reaching their goals, opening new markets, provide some certain information support to opening new markets, and developing their products within a certain markets. For these activities, we do have, as you can see, various applications. What we do, we have conferences where we present what we do right now. We have demonstrator. We are searching for exhibitions, participating in the exhibition to help our members to promote their products and promote CAN-based technology in various application fields. So there are these two branches, technical and marketing one. And after all, sorry, this is 2 times here presented. This is so far what we actually do as CAN Automation. If you are interested in our activities, you want to design devices, or you want to promote your CAN-based products, you're welcome to contact us on this matter. So far, brief information about us, CANopen and CAN Automation, what we do. Now we go to the topic of today's evening, CAN and its connection, what we as CAN Automation offer in this area for Industry 4.0 requirements. So what will be these requirements? Basically, this is not just IoT, but automation of this various factory, making them interconnected on the embedded level of the devices and connected on the global level of factories. For these reasons, you know about cloud, big data collection, trends which are part of Industry 4.0 efforts. So what we actually do in this one will be nicely showed you by examples. This slide shows you how do we see as CAN Automation organization, how our members see embedded CANopen networks. How do we get to the data on the CANopen networks? If I access them remotely or even locally, having them collected the data, whatever they should be, over the cloud portal and gain the access to very specific data on CANopen networks and how this data goes to the end user. So this is just a general scheme, how we how we see this communication path work on. And now we have some real-life examples which are using the aspects of such communication, CANopen IoT communication, at least part of those, but surely as a part of Industry 4.0. One of those is actually energy management system, one example of large charger station, which are residing, for example, in North Germany, and the various aspects of this profile and the systems based on it, designed based on it, access various data, diagnostic data in a pedelec, electric bicycle or electrical vehicles. To access, how to access data, which data I would like to see, the status count of my networks, the security issues with my bike. All these things are actually designed already, and real life example is located actually one of the charge station in Rostock in North Germany. This network for public charger has, for light electrical vehicles, of course, there is a specific one, consists of the very few elements, as you can see this network, connected to embedded CAN. And this data exchanged over this network provide various information and to maintain the operability and monitor the current charging process of this electrical bicycle, for example. Another example where we have meet requirements of Industry 4.0 is the lift condition monitoring. We have a profile, application profile. We have several members of ours, about 40 plus, who develop lift components, and they require, of course, the monitoring of the whole lift equipment and whole lift elevator application. So for this case, they can use the basic scheme I showed in the very beginning, this CANopen IoT communication, but they could do this in a simple way, just having data provided from each single part in embedded CANopen network, CANopen lift network, and pushing this data by CANopen means into so-called gateway, TCP/IP gateway, which can be designed also manufactured specifically. And from this on, the data could go through the cloud or through local communication path into the end user, who collects this data on the lift network. The most important information, this predictive maintenance of the component is done by this means, is done actually in a very simple manner. There are no very big specifics. I just collect the data with manufacturer specific way from this gateway. But the data is coming into gateway from CANopen network, but very standardized CANopen embedded means. So 2 nice examples. Then where do you find this? If you want to have it to design this yourself or coming up with an idea or just want to know this. So for cloud connectivity in general, for IoT, for Industry 4.0, we have certain solutions already provided in the form of specifications. We offer to the certain topics like standardized data interface, which you could find in our basic specification. This is necessary to know where the data, which data do I need to use. And we have also so-called device profiles, like encoders, various sensor kinds, and there is already standardized CANopen interface provided for them. So if you need to implement this in your gateway on your IoT-based solution, this data is already here and you can obtain it. We have also standardized access to embedded network, embedded CANopen. this is specified in 309 specification document series, which is actually TCP/IP communication from to CANopen network. It specifies plenty of things, maps CANopen communication services on embedded level into their TCP/IP based frames, and the services of CANopen, various CANopen services, are mapped into the commands like in Modbus or just simple TCP/IP network. Even for Profibus, we do have a part of this specification. So the standardized access is already specified as well. We can also tunnel the messages as they are, saying we have a transparent gateway, just tunnel messages using fileless transmission media, fileless access, and we have newly developed new technology, CAN FD based with flexible data rate up to 4-5 megabit and up to 64 data bytes, where we have certain advantages on the CANopen embedded network, providing much faster access to the data for these gateways, which should provide the data to the end user over the cloud and so on. We don't have yet certain features, certain properties options, but we're currently working on them. So what is still to do is actually certain new protocols and services emerging in IoT world, like MQTT and OPC UA. So we're working together with OPC Foundation to bring independently field bus neutral data interface. And with MQTT, we actually provide additional to the IoT-based services of ours, certain further features. Security as well as safety is addressed, but this is still under development. We have a certain group, as you can see in the very beginning. I've shown you the technical working group, safety and security. They are currently working on authentication and encryption of data coming through the CAN and CAN FD based networks. We have now CAN FD technology already for more than 3 years, and we have CANopen FD based on it, which provides, of course, certain interesting advantages, which we're talking a little bit later, further on this webinar. What to do if you already know about this, but you ask a question, where can I get the specification? If you want to start, where to start, where to go? So the useful thing is, of course, to ask us, to contact us and ask how do you imagine you would like to have design your network? Would you like to have this CANopen device, this CANopen FD device? How should it all be? But you don't need to be dependent on it. So I provide the list of specification you actually need to know, need to use in case, or at least look into those if you would like to design IoT-based application. So there are plenty of specification actually available for now. We have just a network-based access data in CANopen network. We have multi-level CANopen networking access. We have device description. We have profile descriptions. We have RESTful HTTP mapping onto CANopen mapping onto RESTful HTTP request and also WebSocket protocol, we have XML-based device description and API for programmable devices like PC. So you don't need to have a specific gateway, or may have a gateway, or may reside your IoT application also in programmable device like PLC or similar. So we have also integration of kind of proxies for robotic systems, as you can see in a very last one application specification listed in there. Beside this one, you would like to have a framework and would like probably access all kind of devices located in CANopen network or CANopen FD network. For those devices, we have already standardized profiles with standardized data interface. This you could find out here. Could access being, for most of those, you have to be CANautomation member to access the specification, design them, or embed those data into your gateway application, so you could straightly access the data and you know which data you access on CANopen embedded network and which data you would like submit over the cloud to the end user. Some of these specifications are actually standardized, which means they reach more effective interoperable way of accessing them, which is actually useful, especially if there are plenty of standardized solutions over there. Then you could just reuse those, and in this case, you could just exchange the devices. So far so much about CANopen side in this case, and now we go with a few slides into deep what we have here in this one. Basically, this is a structure of your future CANopen IoT application, and it is related basically to the specification you need to use in every aspect of design of each single part of this structure. So we have CANopen embedded network on physical addressing, which is also available here. And we have an application interface for the PLC or host control devices and so on. Could be designed as well. We can collect the complete process image of process data from CANopen network, as you can see 302-4, and put your also collected into your gateway application. And you know about each devices, how you have address cross-reference, as you can see here. Standardized with, designed with a standardized interface, standardized profiles in 306 as INI-based format, texture format, or 311 in XML-based format. So with these three things coming into your gateway application, you can prepare all the data using 309-5 specification to submit the data to the gateway, to the edge gateway, to the cloud services, or to those around with local communication services which are residing in other neighbored networks. So what we do actually with our IoT things here, 309-5. Well, basically, this is the main specification for this communication path. We have a mapping of CANopen services, of all CANopen services onto TCP/IP, Modbus, ASCII-based communication, Profibus, whatever it might be. We have also management for this gateway capabilities of 309 gateway device. User management and resources management. User management means in this case there are certain priorities for users, and there are certain priorities for the functions in a gateway, CANopen network functions and gateway functions they can access, and is also management with this newly developed specification. So this is one thing. Another thing is actually IoT stuff. We have physical and logical addressing. Physical means I do need to know about CANopen a little bit, so I can map the data straight into RESTful HTTP request and collect the data from my gateway, from my CANopen network, and with this request, I could send a transparent message into whoever sits on an Ethernet-based network, TCP/IP-based network, having the web server, and it can collect this data in there. So to ease or unify the communication in this case, we also designed the logical addressing. Don't mix up with a logical sublink from the slide above, from the slide before. This is just a functional addressing, allowing you embedded technology independent representation of data, where you can design your system and access this on every network in a very standardized way. So with so-called parameter reference designator, as you can see here, shortened as para-RAFD, there is only addressing to the parameters. There are actually several reference designators, but they provide the opportunity to access CANopen embedded system, as in this case, completely independent, without knowledge of CANopen network whatsoever. However, it should be, of course, pre-configured by specialists who knows a thing or two about CANopen. But on a top level, for the end user, if he collects the data and gets these requests, he actually doesn't need to know about CANopen, and the system configured for him hides these specific details in case of logical addressing. Well, this is what we have done now. The specifications are available. You can use them and design corresponding gateways with them. What we have not yet done, which is currently a work in progress, is MQTT. If it is necessary, I do a short brief introduction into this. This is a concept of publisher, broker, and subscriber in this MQTT protocol. Allow me to collect the data correspondingly. It has certain advantages. However, I need additionally design MQTT client and server. For exact information on MQTT, I would advise you to read some literature. We just want to say that we have a goal in mind to map CANopen services onto MQTT to offer this opportunity for our members who implement this. What we do actually, we have a first proposal for that, and we basically want to map, same way as we've done for RESTful HTTP, to map ASCII-based commands which are transmitted simply over the TCP/IP networks into MQTT protocol. I will start in the late autumn of this year. If you are interested, you're welcome to contact us on this matter. We'll be highly appreciating your concerns and your suggestions. So, a couple more slides about MQTT. I've tried to provide here certain relationship, communication path, what will happen in real life with CANopen communication protocols and MQTT. How can we put this onto live on a space? To bind this, to connect this to the previous slide, I've put this colored geometric figures to identify where each participant or which entity sits located. So we have publish subscribe models. As you see, the broker, he manages all this stuff, and each of this participant actually submits the data into broker and could get as many things as it requests. Also is possible to do some event-based communication, which we realize by now only by using WebSocket. So now in the third slide is just a small example how we put this onto ASCII command we already had into this simple form, how it will be standardized. This will be done, as I mentioned previously, in the late autumn of this year. If you're interested, welcome to participate in this and help us out and help yourself out by bringing your proposals. Well, so far this is new perspective for what we will do. And now we go shortly to the new technology we already have, but this will have also impact on our already released, or maybe in a future released, CANopen IoT, because we have CAN-FD based technology called CANopen FD, based on CAN-FD, and due to its certain capabilities, such as 8 times bigger payload for 64 bytes, we have certainly much faster data exchange on embedded level, which may actually cause, beside of migration between the two of those for CANopen for IoT, embedded CAN-based IoT, that would have offer some new opportunities for CANopen FD-based IoT protocol. But this is actually a future. I just wanted to point you out what we have as a protocols, which the data will go faster and very effective way using CANopen. So in CANopen, we have actually plenty of protocols, as you can see from this slide. Most of those are transport protocols we have that gain advantages over from this 64 data bytes. Most of those we are talking about universal STO data objects. The other are of less relevance, maybe emergency plays also a role. But from the perspective, quicker exchange of data, the process data object is of relevance as well. But they both, the first and the third, process data and emergency, they remain almost the same. The universal service data object doesn't exist in CANopen. This is a completely new thing and has certain nice things, effectively reducing and increasing data throughput over the CAN-based network, which has its impact on collection of data for the IoT from CANopen networks. So I just go briefly over this nice opportunities we have. Beside the CANopen-based was only unicast connected data exchange. Here I can do this in broadcast as well. I can collect the data with only one message. I could ask all participants who provide me a certain data to provide exactly this data on this, which actually very effectively would work for lift condition monitoring, because I collect the very same data from different devices, and I could do this in broadcast, which effectively reduces the time of collecting this data. So the nice thing, as you can see here, beside those that you could read in this new specification, where we do have this, there are routing capabilities, allow me to go through several CANopen networks, even through the gateway, without changing anything specifically. I could use a transparent gateway within CANopen network, not outside of CANopen network, but I could access the device across CANopen networks. That would also give certain interesting aspects into this. So just the basic stuff here. This is new structure of such message, which on CANopen embedded level is responsible for collecting or writing the data into the gateway, the process data, which will later goes to the end user over the cloud services, condition monitoring, whatever IoT-based stuff it is. So we actually use, we configure all the data in the large message, which has 64 bytes. We have this possibility now. I will push all configuration into the data, which offers very good configuration capabilities also, which means the gateway which you design, which should access your process data or condition monitoring data, or this IoT into IoT, will do this more effectively, because there is no need to do plenty of configuration. The configuration goes pretty simple, and most of the configuration data is already in the message itself. So still I have the large piece of application data, and I could submit my message in broadcast, which means I could request all devices in a network to submit very same data, similar parameter, which may contain different data inside, collect at once, and this effectively increase my communication speed. The interesting stuff, this remote capabilities of CANopen FD USDO. This is actually this remote USDO things, where I have this kind of network ID and addressing of which network in CANopen embedded network system I would like to access. Basically, I could access in one simple network. Only 127 devices, so I need kind of gateway across multiple networks, but the point is I would have this gateway, can have this transparent gateway, and I have already my identification of whom I ask the data for already in the message itself. So increase the same way of communication on CANopen embedded, CANopen FD embedded level. So far, the other aspects of Industry 4.0 beside CANopen and MQTT will be actually safety and security. So on this level, we do not have this for now for very simple CAN application, but rather more would make a big advantage for CAN FD networks. There are already solutions provided on hardware and the software level, protecting the data by certain authentication of the recipients. There is a software solution from Embedded System Academy. This is CANcrypt, allows you to do this pretty simple way. You can, if you're interested in this, you're welcome to contact us or contact already straight Embedded System Academy. If you're interested in CAN-based security, staff safety and security. We have a working group. We're welcome if you would like to participate in there and help us out and help yourself as well if you want to bring your proposals, your requirements into CAN-based networks regarding safety and security. Well, this is least but not the last one. We're also working for a while now with OPC Foundation. We have actually an agreement on developing a completely independent solution for CANopen data interface, a data model for OPC Foundation. So completely independent from our CANopen IoT or CANopen FD IoT stuff. So there are several solutions, as you can see in there. If you are also interested in this one, you're also welcome to join us on that matter. Please feel free to contact us. Well, regarding OPC, there are still some things to do. We actually have a first working draft, but it's still a work in progress. So there is plenty of things to map, CANopen data and OPC information model, in how to bring this into terms of OPC. We have to define the requirement restrictions to see which restrictions will be applied in this case. These are the things we have to do still jointly with OPC Foundation. If you're also interested more or less about this, so you're welcome to be in this. We distinguish, however, between our activities, so we don't want to break any of our activities in this direction. So we say we do this completely independent, CANopen IoT and OPC mapping. So there are certain features available there, like system-wide designators for IoT, and OPC has its own flavors, which we are not including in CANopen IoT and vice versa. So we keep this completely separated activities, and let's see what we're going on with OPC so far. But CANopen IoT is ready to use. You're welcome to look into this. So there are only a few slides left. I hope we have still time. Based on this one, you learned some things about what we do actually. We have CANopen IoT, we have certain solutions, we have independent solution from IoT, we have our data which are collected into network, the data interface for condition monitoring for lift application. We have data for electrical vehicles, for charging procedure, and so on. And we have CANopen IoT as generic solution for your IoT-based communication. There are specifications available for those. You can use them. There are certain technologies we map into CANopen. We map CANopen into those technologies, such as RESTful, WebSocket, and in future MQTT. We have certain opportunities simplifying the cloud access for this data. We design our data in a way that will be easily transferred into cloud. We have system-wide independent addressing in CANopen networks within the CANopen IoT communication path. We do together stuff with OPC Foundation. we map CANopen into OPC model and allow to embed CANopen into OPC communication environment. And for now, we have certain ready solutions for lift applications, such as condition monitoring. Let's see if we do this in a future extension for this. This is so far all what we do in regard of CANopen IoT with IoT Industry 4.0. These aspects we address now. In the next few slides, I would like to address the certain concepts. Sorry, there's still some things, just a brief overview that you could see what is still to be done in respect of our IoT efforts. And you're welcome, of course, to participate. The activities are not stopped. We actually actively do working on this, maintaining, and do introduce new features. You're welcome to participate in these activities as well. In the next few slides, I would like to draw your attention to our more or less marketing or information activities. Is marketing, of course, that our events, we go into details, application related details, device related details in deep. What is going on there? What you need to know about this? One example of CANopen Lift and embedded special purpose cars. These technical events take place in October this year. They would take place, of course, online. Still, we have Corona restrictions throughout the world, so we don't want people to get sick talking at close distance to each other. Well, beside this, if you're interested in our further webinars, we have plenty of topics around this, which I've just scratched today a little, such as CANopen FD topic, CANFD, CANXL, and SAE. For example, we do this all in all by the end of the year. You will have, if you want to attend our cost-free webinars. Beside this, we have email services for our members and non-members, where you get information what we currently do, what is happening in CAN world, what happens in world of CAN automation, what are new developments, recent activities, new markets opened, new opportunities for you. This is what you can find out if you subscribe for our email services. You can follow us on Twitter, join on LinkedIn, and could contact us by email or phone. So this is all for today.